Hello and welcome. Today we're going to talk about MQTT and how this interface works with our products and can be used. I'd like to start by explaining MQTT communication, so I'll go over some basics first. So, what do you need for this kind of communication? Let's get started. First, we need a client that generates data in our example here. Then we need an MQTT broker, which manages and transfers this data. And accordingly, we need clients that can retrieve this data. In this example, our gears are meant to represent a process data image. And now we have the option to publish this process data to a broker. A topic is assigned to this process data value. This topic can be defined or is sometimes predefined. Let's call it for now process data port 1. And there, the whole thing is then stored in the broker. The clients that want to access the data can subscribe to these data using the chosen topic. And the broker then releases them via publish. Of course, the whole process can also be secured via TLS. And the communication can be found below the application layer in the OSI model. All communication takes place exclusively on port 1883 and or specifically on port 8883. In addition, there is also QoS or quality of service, which covers data transfer. Between the client and the broker, in other words, how securely is the data actually transmitted? There are 3 categories for this. First, publishing with course 0 or 0, which in this case means at most once, so only once. And in this case, no acknowledgement or anything else is sent from the broker to the client. And this data transfer is initiated by the client, also known in technical jargon as fire and forget, meaning it's sent once. The next one is publishing with QoS1. Here, the client waits for an acknowledgement from the broker. If it doesn't arrive, the client sends again. Within a certain period, it will resend this publish message as long as the timeout hasn't expired. This can, of course, lead to the same message being transmitted multiple times during a data transfer, and naturally, the broker must also be able to handle this somehow. That's why there's also the option to publish using another method, using course 2. This means exactly once, so the message is sent only once by the client to prevent this data transfer or duplication of the same data. To minimize this. Here, of course, we have a very high data transfer rate. That is, we have the message sent once, then a certain handshake takes place where the broker sends a publish received, followed by a publish released from the client, and finally the whole process is concluded by the broker. Naturally, this requires certain resources and time compared to course 0, but in return, we have a certain level of security that the data has actually arrived. Before we take a look at all of this on the web server of the IO Link master, let's first go over the theory. So we now have the setup where we have an IO Link master with various IO Link sensors that provide process data via the IO Link interface, and theoretically the master could also be connected to a field bus, but in parallel to this field bus, we can also transfer data via the MQTT interface to a cloud, a server, or something else, in other words, to an IT level. In this example, we again have a broker and in a sense clients that can retrieve the data again, that is, can subscribe to it. Our master can only publish. That means it can send data to a broker with a certain topic. The topic can be set on our web server, or you can use predefined topics. And the other clients can subscribe to this topic, that is, subscribe to it and then receive the data from the broker. These data. In this case, the broker is not included in the master. The master is a separate client on its own. After the theory comes the practice, so now let's take a direct look at the example of the IO Link master to see how it works with the MQTT interface for data transmission. For this, I have already installed a Mosquito MQTT broker locally on my PC. It's up and running. I have also already logged into the master, meaning I have assigned an IP address and authenticated myself. I have also already activated the IO link port and connected it to the corresponding IO link device. And now I can already see here that I am receiving data. On the one hand, here are the raw data and then the data parsed or interpreted from the IODD, as you can see, which can also be transmitted. But if we want to take a closer look at all of this, we need to go into the settings here and into the IoT section. This is where the basic settings for the MQTT interface are located. We can see here that the connection status is currently not connected. There is no connection between the client and the broker. However, we can see here that an IODD is already loaded, which is also available and everything is in order, so it belongs to the corresponding IO link device. This is essentially the setting where, later on, with the corresponding masters, we can parse the data and transmit it, not just as raw data. But I will go into detail about that in a moment. A bit further down, you will find the connection settings, which means I can assign an ID to the MQTT client here. Here I then have the option to enter the connection to the MQTT broker. I can assign or designate it a custom prefix. And on the right here, I also have the option available to set what the last transmission should be that is sent if the connection is ever interrupted. This way, you will always receive a timestamp and the status accordingly. In addition, I can activate my connection or my status here, meaning that I want to connect to this particular broker. And down here, I can also enter the identification. For example, if I need to log into the MQTT broker, as is the case in this example, I can save the whole thing. As soon as I have saved it and the connection is active, I can also see this by a certain timestamp, how long it has been active, which broker I am connected to, meaning which IP address, and the status here as OK. If we scroll down again, we have another menu here that we can open, and now it's about the topics. So we have general topics here and we have port-specific topics. With the general topics, for example, it's about the identification of the master, about the master events in general. In other words, you can already see here that we have predefined topics, which you can also copy out and then subscribe to via the broker. But what I can also do is generate a new configuration here and have the option to create my own topic with the corresponding data type and additional settings. So I'm also free in terms of configuration here. Basically in every port. There is also a port-specific topic that can be obtained, which then, of course, transfers the respective topics according to the individual port settings. But now let's take a closer look at them. For this, I'll switch to a tool that allows me to subscribe to an MQTT broker. This means I have already predefined the necessary settings here so that I can actually connect to this MQTT broker. So just like with the IO Link Master, this tool is also a client that wants to connect to this broker. Now let's connect everything here. We can see here that the connection status is okay. Then we can select subscribe here. And if we subscribe using the hash symbol here, we'll get all the topics transmitted by the master displayed directly. So let's start the whole thing now. And now on the right, we can see that we're receiving all the data being transmitted. Let's stop the transmission so we can take a look at the data. Here we have the prefix and then the corresponding topic from which data has now been sent, indicating that something has changed. Then we have the data byte from the device. As we can see here, we have a timestamp. Of course, we also get the type and the data. And here we can now see everything in a raw data format. With this sensor, we always have 4 bytes that belong together. This means that here we now have these 4 bytes according to a process data type. And we can, for example, take a look at them here because we also get the data passed via the IODD. Here again, we see the timestamp with the corresponding data type. And now we see this is basically the output when these 4 bytes are passed. Based on the IODD, I get the corresponding indication of what kind of data it is, in this case PD, process data, VRMS on the x-axis, which means velocity RMS on the x-axis, and the corresponding value, which is already parsed directly into the correct format. This means that I now have from the client side, from my master, these data from the corresponding sensor have been published to a broker. And with a separate tool, I have subscribed to these data via the respective topic and received them. These data are transmitted. Let's continue with the CMTK, where we want to take a detailed look at everything in the same way. With our Condition Monitoring Toolkit, or CMTK, things look a bit different. That's why we'll start with the theory again here. You can also see here there's a gray box, which also means internally that we have an industrial PC running on its own with 4 I/O link ports, and I/O link sensors can also be connected there. However, with this industrial PC, we can still send the data externally via the MQTT interface. Here's a major difference. Internally, we already have a broker, an MQTT broker included, which collects the data. Then in our example, we again have clients that want to access this data from outside. And we also have a Docker system internally, which can be installed or set up. And the data from the broker can also be subscribed to there. This means that internally, we only have the option to publish the data to a broker for now. We also don't have a subscribe command or a function that the CMTK can perform. And now these data are stored on the internal broker. Using a pre-established topic, the relevant data can then be subscribed to either from outside, externally, or internally via the Docker system. And these data are then published again accordingly. And in practice, it looks like this. Here we have our dashboard from our CMTK, and here we have the option to look at the network settings under the settings menu, because that's what matters. That's what it's about. We need the IP address of the CMTK in order to access this broker. In our example, it's 10.10.10.30. We also have the option here to look at and activate the MQTT interface under IoT communication. There are various configuration options here. We have the option to use port 8883 to communicate via TLS encryption or via port 1883 without encryption, which is what we want to do in this case. What we can also do here is specify whether we want to connect with or without authentication, that is logging in without a user. But now we want to log in with a user, so we've set a certain password here, and you can see down here. I'll go ahead and save everything, and you can see down here. Now how this topic or the topic structure is or can be set up. There are different options. There is always the standard header. Then there is a device alias, which also includes the specific port. And then here we have the option to transmit the events, the units, or the data, specifically the data from the device with IODD parsed data. Or if I want the raw data, then simply here you can see it without IODD transmission. We've already saved everything, and now we can go back to a tool. In this case, and take a look at it. This time, we're not on the locally installed Mosquito broker, but we're directly on the CMTK. You can also see it here via the IP address through the respective port, in this case without TLS communication. We've entered the user credentials. Everything fits so far. Now we can connect here and see we are connected and can now, using the subscribe button and the hash symbol, receive all the data, meaning all topics. And now we receive the processed data here based on the IoT, which is being transmitted here. They are parsed directly again. That's everything on the topic of IoT, or more precisely, MQTT communication via the CMTK. Lastly, I would like to talk about MQTT communication in the evaluation unit of the RFID device. In our case, it's also called BISV. Here we have the option to connect read-write heads to 4 ports. This is where the RFID communication is ensured, and we can then transfer this data back into the IT world. Here, just like with the IO Link master, we do not have an internal MQTT broker. This means that, once again, we first need to have an external broker and also external clients that can access or more precisely subscribe to the data. And again, we publish the data to a broker. These settings can once again be configured in the web server, which we'll take a look at in a moment. And external clients can then subscribe to the broker using the respective topic and will receive the data as it is published. The interface or web server of the BISV, that is our RFID evaluation unit, is structured very similarly to that of the IO Link master. There are a few differences in MQTT communication which I'd like to show here now. Namely, it's about wanting to transport RFID data based on whether the data carrier is present, whether it has been detected, and whether it can transmit the data. And we can also select all of this. There are in fact different types of memory. For example, in the data carrier, we have the option here, or rather, you can make the setting in the read-write head, but the memory itself is in the data carrier. And there I can then transmit the type and serial number. If this is activated here, as soon as the data carrier is detected in the field of the read-write head, the type and serial number will be transmitted automatically. If this is deactivated, then I can, among other things, have the process data in the user area transmitted to me. Not all of it, but a certain amount. That's all for this setting. I think it's important to simply know which data is being transmitted here. Here we also have data transmission similar to MQTT transmission with the IO Link master. The data is transmitted when a change occurs. And if we now look at the whole thing in IoT communication, we see the same configuration options here again. We can activate the whole thing here. Here we are again communicating with the internal, or rather local, mosquito broker that was installed here. And we connect to it with the respective authentication logins. And now we see here, if we save the whole thing and wait a moment, we can use the time well. We see no further topic settings down here. This means that in the system of the evaluation unit, all topics are predefined and specified in the user manual. I can't create my own topics. But now we see up here, we have an active connection and can now again go to our tool where we can subscribe to this data. We are already logged in here on the local mosquito broker and can now subscribe to the data here. What we see here now is that the data is updated from time to time. Specifically, it's about the identification data, which is then queried in a cycle. But if, for example, I now hold a data carrier in front of the read-write head, then I can mute the whole thing here. And now I see that data has been transmitted. And here we can see that these are incoming data from the data carrier. This means the data carrier is within the field of view. The tag UID is being transmitted here. No user data is being transmitted because we only want to transmit the type and serial number here. So that's the case here in this particular situation. And we have a timestamp. Here I also have the type of the data carrier. So the data is being transmitted to me here. If we now, so to speak, activate everything again so that we want to generate the data recording, we can remove the data carrier. I'll mute everything, and now we can see here that these data are gone. Here we have a completely different communication. We also have process data, but since we have RFID technology, it's relevant whether the data carrier is present or has left, and which data carriers are actually present or have left. Accordingly, the process data changes here because in this example, the process has been shown to be very slow, not as frequently as with process data that is generated via another IO Link participant through the master. That's all for the whole IoT, or rather MQTT, communication with our devices.